Yeah, good morning everyone. This is Amit Pandey, and today I'm going to start the concept of alternating current, that is chapter number 7 of class 12 here. So let's start with the topic alternating current. Now, see, before starting the concept of AC, let me give some idea about the DC here, that is direct current. Direct current. Because for understanding the concept of AC, we need to differentiate exactly what is the difference between AC and DC here. So let me start a brief introduction of only DC current here. For example, in case of DC current, the magnitude, or we can say the direction of current remains same. Means we can say that the direction of current is uniform in nature. Suppose for the entire interval of time, if the direction of current is positive, under that condition we can say that this is a DC current here. Or suppose if it is changing continuously, now after suppose some interval of time, positive current becomes negative and later it become positive, that will not comes under the concept of DC current. When direction is uniform in nature, when it is not changing, that comes under the concept of DC current here. So for that, let me take an example of graph here. Suppose I have taken time on the x-axis and current on the y-axis, and we are getting the graph of current and time in this manner, means that is parallel to the x-axis here. Now regarding the interpretation or observation, suppose I have taken few interval of time, suppose time t1 here and suppose time t2 here and time t3 here. I have taken three different time t1, time t2 and time t3. That will be suppose 1 second, 2 second or 3 second. And suppose at this point we are getting current 5 ampere. Okay. Now what is the meaning of this graph here? At time t1, suppose at time t1 second, we are getting positive 5 ampere. Positive 5 ampere at time t1 second. Now next one, at time t2 second. Again we are getting the same current. Regarding the direction, if you see, we are getting again positive 5 ampere here at time t2 second. And for the next interval of time, again we are getting same current, that is 5 ampere at time t3 second. So for every interval of time, what is the meaning of current here? We are getting current in positive directions only. So this indicates the nature of current, that is DC current. Let me take few more examples so that it will be clear to you. Now, suppose again I am taking the same coordinate system here. Suppose on the x-axis I have taken time t, and on the y-axis I have taken current I here. And the nature of the graph between current and time is coming in this manner. Okay. And let me take few values here. Suppose 0 second, 2 second, 4 second and 6 second. Now between 0 to 2 second, at time t, 0 to 2 second, what is the value of current? We are getting positive. Means the direction of current is positive current here between time 0 to 2 second here. Now regarding the next interval of time, from 2 to 4 second, from 2 to 4 second, if you see again the curve is positive curve, means we are getting positive current. And next interval of time 4 to 6 second, again we are getting positive current. Means what is the conclusion point here? For every interval of time, if the direction of current is same, see, for every interval of time the direction is positive in nature, means it is not changing. Suppose after 2 seconds, if direction become negative, then it will comes under the concept of alternating current. But if it is uniform in nature, if it is not changing, that's said to be DC current, if we are discussing regarding the current here. Same statement for the voltage also. Suppose between voltage and time we have made the same graph, then that will comes under the concept of DC voltage here. that is potential difference. Fine. Suppose, let me take one more example here. Time t and current I have taken here. And this time we are getting the graph in terms of negative axis like that. Suppose time 0, time 2 second, time 3 second, and time 4 second. Okay. So what is the conclusion point here? From 0 to 2 second, we are getting negative current. From 2 to 3 second, we are getting negative current. And from 3 to 4 second, again we are getting negative current here. In this manner, you can get the value of current on this y-axis. So that will be a negative current. Again, the same statement here, the direction of current is not changing here. It means that that is DC current. So we have to keep only one thing in the mind. When amplitude changes, so we don't have to focus on the amplitude. Current can change, the value can change. It can be 5 ampere, it can be 2 ampere, it can be 0 ampere also. But if direction changes, that will not be an example of DC current here. Direction must be uniform in nature. If positive, for the infinite interval of time, it will be positive. If negative, for the infinite interval of time, it must have to flow in the negative direction. So I hope it is clear to everyone. Now let me start with the concept of alternating current here. So the heading alternating current, that is AC. Actually it is alternating current cycle. So that point we'll understand later. So till then, let me explain with the same points here, alternating current, that is AC here. So in case of AC, we have a definition here. When direction changes. Direction means when the direction of current changes after every fixed interval of time. Fixed interval of time. Then we can say that the nature of current is alternating current. If the physical quantity is voltage, then we can say that the nature of voltage is alternating voltage here. So one thing is compulsory. Regarding the magnitude, I am not focusing here. Regarding the direction, the main concern point is direction. If direction changes continuously after fixed interval of time, then we can say that the nature of the current is alternating current. For example, suppose at x-axis I am taking time t. On the y-axis I have taken current I here. And we are getting this type of graph. And let 0 second, let this time is 1 second, 2 second, 3 second, and 4 second. Fine. So here you can see from time 0 to 1 second, the direction of current is positive. Now from time 1 to 2 second, from time 1 to 2 second, the direction is going to change here. You can see now it is negative. Now direction is negative here. And then from 2 to 3 second, again it changes and it becomes positive. And so on. Means after every seconds, after every 1 second, you can see the direction of current is going to change. That is the meaning of fixed interval of time. Here, the fixed interval of time is 1 second. After every 1 second, positive current become negative and negative current become positive. So that will be the example of alternating current. Now again, one more point here. Alternating current doesn't mean that it is purely sine curve or sinusoidal curve. It can be triangular also. For example, here, suppose time on the x-axis and current on the y-axis, and we are getting this graph. Now see again, positive current, negative current, positive current, and negative current. Means what? What is the conclusion point here? Direction must have to change. If direction changes continuously, that will be the example of alternating current here. Whether sinusoidally or in terms of trapezium, in terms of triangular, it doesn't matter. But direction must have to change here. So I hope this much example is enough for the understanding of alternating current and direct current. Now let me start with the next concept of the chapter, that is average value, or simply I'm taking the example of average current here. So the heading is average current. So regarding average current, we have a symbol here IAVG, or you can use I and bar over it. So these are the few symbols for the representation of average current. Now regarding the word here average, in 11th class we have got the concept of average velocity, average speed, average acceleration also. So what is the meaning of average here? When we deal about the average, so one thing come in the mind regarding a time. So time period in case of average value, time period is large. So when we discuss about the large interval of time, under that condition, the value is average value. In terms of current, that is average current. If we discuss the same things for the very small interval of time, at fixed interval of time, exactly suppose for example, I need to know what is the velocity of the, what is the speed of the car exactly at 1 second. What is the speed of the car exactly at 10.1 dot. It means that we need specific values, fixed value. That will be example of instantaneous value. So in case of instantaneous value, the time period will be very small. But here, in case of average or average current value, the time period will be larger. And due to that reason only, I'm taking delta for indicating large value here. If small d means very small value. Fine. So how to define mathematically average current here? So IAVG, average current, is equals to delta Q by delta T here. Charge per unit time. So regarding I average, change of current, change of charge or difference of the charges between 2 points or for the two interval of time divided by the difference of the time here. So delta Q by delta T. So for this equation, first we need to calculate the value of delta Q here. Now, let me give one more concept before the mathematical interpretation of this I average. Sources. So first point here, in case of DC source, in case of DC source. So suppose I'm taking battery here. So here positive terminal and negative terminal. When we apply positive terminal here and negative terminal here, it is very clear to every individual that current will flow in this manner. Suppose current I here, because current will flow from high potential to low potential in case of DC current. Suppose same parameter I am drawing for the alternating current, suppose AC source. So this will be the symbol for the representation of AC source, and two terminal I have drawn here. Now I have one question. In case of AC source, what is the direction of current? So now it is a bit confusing in this case, because suppose if I say the direction of current is here, after some interval of time it will change, it become opposite direction. Again after some interval of time it moves in the forward direction. Means what? At every interval of time, after some interval of time, direction is going to change. So it is really not possible to define the direction of current here. For this reason only, whenever we discuss AC source calculation, we'll discuss for very small interval of time. For very small interval of time. Means what? I just want to focus on the instantaneous value. Means we have to calculate instantaneous value for the direction. For example, in case of current I'm telling, so we need to calculate I instantaneous. Suppose if I say at exactly time t is equals to 1 second, and exactly at 1 second I'm taking the snap of that source. So 100% will get one direction. Might be for next second it will be opposite direction. But for 1 second we will get a fixed direction. Might be in forward direction or maybe in backward direction, opposite direction. But it is confirmed that for a small interval of time we'll get the direction here. So it means that small interval of time represent what? Instantaneous value here. So for the interpretation of average value, we'll do the same here. We'll go for the very small interval of time. So I instantaneous here, that will be equals to dq by dt. Okay, instantaneous value, small d means very small interval of time. Now we have to separate dq here. So dq will be equals to I dt. Suppose I instantaneous is I here. Now if we have to calculate total charge, then we have only one method. We have to integrate on both the side. So integrating on both the side and applying the limit here. So limit for the dq is what? Q1 to Q2. Suppose initial charge is Q1 and final charge is Q2. And here dt. So suppose initial time is T1 and final time is T2 here. So after that we can write this equation. Integration of dq is what? Q. I hope you all are clear with the concept of integration, as it comes under the basic mathematics tools here. So that's why I'm not focusing on that part. By default, I considered that integration of dq is clear to every individual. So integration of dq is q, and then we have to apply limits here. Upper limit q2, lower limit q1. That is equals to integration from t1 to t2 I dt. Now what is the next step? We have to apply limit final minus initial, means upper limit minus lower limit on q here. So q2 minus q1, that will come, it is equals to time t1 to t2 I dt here. Now let me take next page. Now see, q2 minus q1, can we write q2 minus q1 is equals to delta q, change of charge? Q2 minus q1 is delta q, and that is equals to integration from time t1 to t2 I dt. Now come for the equation number first here that we have written here on the previous slide, that I average is equals to delta q by delta t here. Now see, in place of delta q, can we put this value? Integration of t1 to t2 I dt, and in place of delta t, can we write t2 minus t1? So finally we have got the equation for I average, that is equals to integration from t1 to t2 I dt divided by t2 minus t1. Let me correct it, it is t1 here. T2 minus t1. Final minus initial. So we'll keep this formula in our mind, and now I'm just taking one example which comes under the concept of I average here, so that we can get the clarity of this topic. Suppose I is equals to 4t cube plus 2t. I is a function of time, and that is equals to 4t cube plus 2t, and we have to calculate I average at 2 seconds. Find the value of average current at 2 seconds here. Now again we have to use the same formula for I average, that is I average is equals to integration of t1 to t2 I dt divided by t2 minus t1. Now please put the value of I here. So I is how much? I is 4t cube plus 2t. So integration of t1 to t2, what is t1 here? From 0 to 2 seconds we have to calculate the I average. So in place of t1 we have to put 0 second. In place of t2 we have to put 2 second here. So that is equals to I, and put the value of I, 4t cube plus 2t here, and then dt, because it is I into dt, and divided by t2 minus t1. What is t2? 2, and t1 0. So 2 minus 0 here. So finally we have got 4t cube plus 2t into dt. Now we can write this in terms of two terms here, like 0 to 2 4t cube dt plus integration from 0 to 2 2t dt, and whole divided by 2 minus 0, that is 2 here. But one thing from my side, try to integrate directly, don't separate into two parts. Just practice in such a manner so that you can get the answer directly, otherwise it will take lots of time. So finally we can write this equation, that is equals to here 4t cube dt. What is the integration of 4t cube dt? So 4 is constant, so please keep out of the integration part, and then integration of t cube, t4 by 4. So multiplied by t4 by 4, and again put the limit, that is from 0 to 2 second. 0 to 2. Then plus, here 2 is constant, so keep out of the integration part, and the integration of t dt is what? T square. So here t square by 2, that is the integration of t. And now apply the limit here. So 0 to 2 and divided by 2 minus 0, that is 2 here. So you can see 4 and 4 we can cancel, and 2 and 2 we can cancel here. So finally we are getting t to the power 4 and limit is 2 to 0 plus t square and limit is 2 and 0 here divided by 2. Now I'm just leaving this lower limit because lower limit is 0, that will not give any values. So you will get here t4 square, means in place of t you have to put 2 here, upper limit. So 2 to the power 4 minus, in place of t you have to put lower limit, that is 0 to the power 4 is how much? 0. So I'm skipping that part. Plus, in the same manner, in place of t you have to put 2 here, so 2 square, and then in place of t you have to put 0, so 0 square will be 0, so leave that part, divided by 2 here. So 2 to the power 4, 16 plus 4 divided by 2, it means here 20 by 2, that is equals to 10 ampere. So finally we have got I average, that is 10 ampere here. So in this manner we have to calculate average value by using the formula integration of t1 to t2 I dt divided by t2 minus t1. Now let me go with the next concept here. Suppose let it is equals to I naught sine omega t. Suppose I have taken one function, that is a current, which is a function of time, I naught sine omega t. Now here what is I naught? I naught here is peak value. Omega here is angular velocity. Angular velocity, and t is the time for which we are finding current here. Okay, and regarding the omega is how much? 2 pi f, or you can write omega is equals to 2 pi by t, because frequency is what? That is reciprocal of time period 1 by t here. And what is capital T here? Capital T is the time period. So we have a difference here with capital T and T. Capital T is the time period, means after which interval of time the graph repeat itself. For example, let me take one example here. Suppose suppose 0, t by 2, then t, and then here 2t. Okay, so you can see 0 to t by 2, and then after t by 2 to t, and again after t the graph repeat itself. Okay, so let me make changes here. Here 2t. Now see, after every t interval of time the graph repeat itself. So what is the meaning of time period? When you find the time period here, time period, so from this point to this point graph repeat itself, so t minus 0, that is equals to t here. Now see in this case also 2t minus t, because after this interval of time, after this time again graph repeat itself. It means that the time period is how much? T. So time period is the parameter, we can say time, after which the graph repeat itself. But in the same equation we have got a small t. What is small t here? Exactly at which time interval you need to calculate current value. Suppose if I need to calculate this current value at 2 seconds. So here in small t we need to put 2 seconds here. Fine. Now next point. Suppose if it is given I naught sine omega t, that is a sine function, or simply sinusoidal function, how to get the average value for this curve here? That is the points we are taking in this topic. So Later we'll go for the mathematical interpretation of sinusoidal wave. But before that, let me take the mathematical equations for I naught sin omega t, and we'll calculate what is the average value of this equation I naught sin omega t when time period is 0 to t second here. So suppose this is the graph here. And from 0 to t, we have a time period here. And again 2t and so on. Okay, omega t and current I. So how to calculate average value? We have to use the same formula. Integration from t1 to t2 I dt divided by t2 minus t1. So here what is t1? T1 is 0 and t2 is capital T, because after t interval of time the graph repeats itself, and we are finding I average from 0 to t second for full cycle, or you can say for complete cycle. For complete cycle, we are calculating I average here. So 0 to t and I. What is the equation of I here? That is I naught sin omega t. See, we have taken the equation here. I is equals to I naught sin omega t here. So in place of I, we have to put the value I is equals to I naught sin omega t dt divided by t minus 0 here. Now let me take next slide. So I average, that is equals to integration from 0 to t I naught sin omega t dt divided by t minus 0 is nothing but it is t here. Now in this equation, can we say I naught is constant? So keep I naught out of the integration part. Now integration of sin omega t dt, separately I am integrating here. So integration of sin omega t dt will be what? Minus of cos omega t, and again we have to differentiate this omega t. I hope you have a clarity how to integrate sin 2t, how to integrate cos 2t, integration of that part and then differentiation of rest part, but that part will write on the denominator. For example, here integration of sin omega t is minus cos omega t, and then differentiate this omega t. So that will be omega, but that part we will write on the denominator. So finally I'm writing the value minus of cos omega t by omega with the limit here 0 to t and divided by time t2 minus t1, that is t here. Fine. Now let me keep all the constant part out of this bracket. So it will be now equals to I naught by omega and minus, and also I'm taking out of the bracket here, and finally cos omega t and the limit is 0 to t here, 0 to t, and on the denominator t here. Now then next step, minus I naught by omega, and inside the bracket, as we know omega is what? 2 pi by t here. So same changes I'm making here also. Cos omega 2 pi by capital T multiplied by small t from 0 to t here. Now next I am just going to put the limit. It will be equals to minus I naught by omega, and inside the bracket cos 2 pi by t, and in this t we need to put upper limit, that is capital T, minus lower limit cos 2 pi by t multiplied by 0. So what we are getting here, say t and t get cancelled, so cos 2 pi, what is cos 2 pi? That is equals to 1. Now see, cos 2 pi t into 0, it is cos 0. Cos 0 is how much? That is equals to 1. Fine. So finally what we are getting here, we are getting minus of I naught by t multiplied by 0, means complete value we are getting 0 here. What is the conclusion point? That I average for complete cycle, that is from 0 to t is how much? That is equals to 0. So this is the conclusion point for the sinusoidal curve. When the time period is 0 to t, I average will be 0 here. Now for the next class, what we have to find here, Same things we have to calculate, means same I average we have to calculate, but for different time period. Suppose I average for time period 0 to t by 2 second, means we can say for half cycle, for half cycle. So this is the points we have to calculate for the next class. When the time period will be half, that will be from 0 to t by 2, whether I average is 0 or we are getting values of I average here. So let me give the points. When you find I average for the time interval 0 to t by 2 seconds, you will get the time that is equals to 2 I naught by pi here. So this one is the task for the next class. But before that, please try to get the same result with all the methods that I have given here. And if not possible, then we'll discuss on the next class here. So I hope it is clear to everyone. And on the next class, I already discussed that. We'll discuss for the finding of I average for the half interval of time. Then we'll discuss what is RMS value, and regarding the circuits, what is RL circuit, what is RLC circuit, and how to find the impedance of that circuit. So till then, thank you everyone. See you on the next class.